Hey Sabers, this is Miss Marsh. Today we're going to look at section 4.2, which is on patterns and linear functions. What you're going to want to have on you is your notebook, a pencil, and then make sure you may not need a calculator, but it might be better to have one close. So what the video is going to focus on is how to identify and represent patterns that describe a linear function. A little bit later we're going to take a look at nonlinear, but today's going to be just linear functions. So first, we need some vocabulary. So please make sure you write down this vocabulary words. A dependent variable. You probably heard about this in science. What these are, this is the variable that changes and depends, hence the name dependent variable, on the independent variable. So a dependent variable, usually we name him y. So usually y is our dependent variable. Now an independent variable, make a little line here. Your independent variable, this is the variable we will change. This is the one where we usually plug in values. This variable changes the dependent variable. Now, we usually call him, though not always, we usually call him x. So our x is our independent variable and our y is our dependent. Inputs. Inputs are the numbers which we place into a function. And we'll talk about functions a little bit later in this video. Outputs are the numbers we get out of a function. Our input are usually what we know as our x's, and our outputs are usually our y's. If you kind of think of it as a machine, we put some numbers in and we're going to get something different back out. Those are our outputs. So our problems today are going to be a lot of patterns, making a table, and then also graphing it. So remember those little graphs I gave you this morning, or during class today, you're going to want to make sure you have those near you, so then you can graph the graphs when we get to that point. So in this diagram below, we need to find what's the relationship between the number of rectangles and the perimeter of the figure they form. Represent this relationship using a table, an equation, and a graph. So you are going to want to get down this diagram down here. It doesn't need to be perfect, not artistic, but just good enough so you can kind of see what's going on. So I'm going to start filling out my table before I create the equation. So my table, I have one rectangle in my first part. Now my perimeter is all sides added up. So this is 1. This other side here has to be 6. And so does this have to be 1. So I'm going to add this up. 1 plus 6, 7, plus 1, 8, plus 6, 14. So my perimeter is 14. So now 2 rectangles. Now I'm going to add here again. So I got 6 and 1 and 1, so I got 6 and 6. That's going to make me 12. And I have 4 ones, so I get 16. 3, I have 6, 1, 1, 1. So I have 12 and 6 ones, so that's 18. Hopefully you're seeing a pattern kind of be generated on this side. Now 4 rectangles. Got a bunch of little ones there, so I got 12 again. And then I'm going to get 8, so I'm going to get 20. So now, I filled out my table. My table is the key to unlocking my equation. So if you remember, y equals mx plus b, That was the form of linear equation. You should remember it back from Math 8 last year. So if we look at these, I need to figure out my m and my b. So my m, the easiest way to find my m is the first difference and the second difference. The first difference is your output difference. So I'm going to find the difference between here, here, and here. Now, it should be the same. So if I go here, 14 to 16, that's an adding of 2. Do you see that? Again, I'm going to add 2 from 16 to 18. And 18 to 20, I'm going to add 2 there. Now let's look at our number of rectangles. From here to here, I'm adding 1. Also adding 1. And oh look, I added 1 again. It's kind of nice, and we'll talk about when this actually happens. This is what's good, lets us know that we actually have a linear function. So what I'm going to do for my m is I'm going to put my first difference, the y change, 2, over my x change, which is 1. So I got y equals, there's my m, x. Now I need to find my b. Now, the easiest way to find b is wherever you're going to get a 0 in your table. So now if you notice here, I don't have 0 on this side. I don't have it. So I'm going to find what would I had for 0. So if I go up, if you notice, I'm going up by 2. So if I need to go this way, I'm going to subtract 2 from 14. So 14 minus 2 gives me my 12. So I'm going to take this 12, I'm going to put it right there. So my equation is y equals 2x plus 12. So now let's graph. So I have our table filled out here. So I'm going to fill in my ordered pair column. You do not need to write this column, but I'm writing it for the fact of we can do it. So I'm taking 1 and 14, so I'm taking the numbers that I have and putting them as an ordered pair. 3 and 18, and 4 and 20. So now, the hardest part on doing these graphs is figuring out what am I going to do for a scale and what am I going to put. So first of all, I got a label. So right here, my x value is the number of rectangles. And you can tape these graphs into your notebook if that helps you. On this side, I'm going to be going perimeter. There we go. So now I found my easiest way. I went by ones. So I'm going to go by ones every other line. So then I have a little bit more room to write. There we go. There we go. Finally drew 5. Now, I went by 2s every single line, otherwise I didn't have enough room. So I did 2, 4, 6, 8, 10, 12, 14, and so on, and so forth. And I went up to 24. So then, I'm going to graph my point. 1, 14. So 1 and 14. 2 and 16, 3 and 18, and 4 and 20. Now notice how I'm going up 1 over 2 a bunch of different times, which is really good. Notice how though mine, how it's a straight line. Doesn't have any curves in it. It's just a perfect straight line. That is very important. That is a straight line. Again, some more vocabulary. Now, a function. This is probably one of the most important things in math. A function means that each input has one unique output. Now, notice how I underlined 1 a whole bunch of times. That's the most important part, and they all need to be unique. So here's some examples. An example of a function looks like this, with just some ordered pairs. I could have 1, 8, 2, 9, 3, 10, and 4, 11. Notice how all my inputs have only one output. 1 is not paired with another number. 2 is not paired with any other number besides 9. And 3 is only paired with 10, and so on and so forth. So an example of not a function would look something like this. 1 and 8, 2 and 9, 1 and 10, and 11 and 11. Notice how 1 is to 8 and 1 is to 10. He can't be to both 8 and 10. He can only be to 8 or to 10. So this is what makes that not a function. These double 1s cause me problems. Now, a linear function is a function when graphed forms a straight line. Another thing, the values in our chart go up by a constant value. And just as a side note, they can go or down. Just add that right there in there. So they can go up or down by a constant value. If you notice, they've been always going up by 4, or they always go up by 2. They can't go by 4, 3, 2, oh, let's do a 5. They have to go up and down by a constant value. So let's take a look at this one. The table shows the relationship between the number of photos X you take and the amount of memory Y in megabytes left on your camera's memory chip. Usually it's about gigabytes, but that's alright. Is a relationship a linear function? Describe a relationship using an equation and a graph. So the best way to find if it's a linear equation or not, or a linear function, excuse me, is we're going to see is my differences of my y's and my x's constant. So I'm going to go right here. 512 to 509, it looks like I subtracted 3. So it takes 3 megabytes, it looks like, per picture. So it looks like there I went down by 3 again. And there I went down by 3 again. So that's good. That shows my y's have a pattern. Let's see. Do I have a pattern over here? Looks like I'm going up by 1, another up by 1, and another up by 1, which is good. So if they all have the same, I can say, yes, this is a linear function. So then what I want to do is describe the relationship using an equation and a graph. So my equation, I'm going to start y equals, I'm going to find my m. Now if you remember my m, that was the difference of my y's over the difference of my x. So that would be -3 and a +1. Now, my b is where always the 0 was for x, and I always wanted my y. So, oh, look at this one. They actually gave me what 0 is. So I'm going to follow over, and 512 is my b. Alright, so problem 4. They want me to find, is the relationship a linear function, and then also describe the relationship using an equation. So I'm first going to find, is it a linear function? So does it go up by constant values? So I'm going to first always look at my y's. So it looks 8 to 10, that's an adding of 2. 10 to 12, adding 2. 12 to 14, I added 2. Let's check here, my x's. Added 1, added 1, added 1. That is good, so that means yes, I do have a linear function. Now, I need to make an equation, and we're also going to graph this one. We didn't graph number 3, but we're going to graph number 4. So now, I'm going to find my equation. So I got y equals x plus. Now, I need to find my m. Now, if you remember, my m is always my y, my difference of y over difference of x. So 2 over 1, and my b is whenever my x was 0, it's going to be my y value. So my x was 0, my y was 8. So if I simplify that, I can also write it as y equals 2x plus 8. So let's graph this one. Let's see what kind of graph I get out of this. So I'm going to first, don't have any labels for this one, and that's alright. So I'm going to first figure out what I want to do for points. And it looks like I can go 1, 2, 3, and 4. Look how I'm skipping a line just so it's easier for me to see. And I got 8, 10, 12, and 14. It looks like I can go by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So now, 0 was for 8. So 0 is right here. Go up and put a dot at 8. 1, I'm going to go up to put a dot at 10. 2, I'm going to put a dot at 12. At least I thought I was going to put a dot at 12. There we go. 3, it's going to be at 14. There we go. Now if you notice, if I connect my dots the best to my ability, I actually have another straight line. That also proves that that's a linear function, because any linear function will graph and make a straight line. Last problem for the night. Does the set of ordered pairs 0, 2, 1, 4, 3, 5, and 1, 8 represent a function? So now if you look back at your notes, and I'll flip back here, I said a function had one unique output for each input. So let's take a look here. Do each one of my inputs, aka my x's, have a 1 y value paired with it? So if I look here, 0 is paired to 2, 1 is paired to 4, 3 is paired to 5, and 1 is paired to 6. Wait, hold on. Can 1 be paired to 4? And? Can he be paired to 8 if he's in a function? No. This is not a function. That's just not going to work. And the reason behind what I would say is 1 does not have a unique y value. That's a wrap. See you later.